Wait. Hello, people. Oh no, my camera. Okay, looks like it's back to normal. But welcome, people, to the stream. I have switched my camera back to my normal camera because the other one was not working at all, and that is a shame. I wish that the other camera was actually helped me out to do my streams correctly, but it did not. So I must just struggle. I must use this one for now, even though it is not the best. But today we're doing some calculus, and today we're going to be learning and figuring out the substitution method and different things there, because I don't know how that works, and we're going to figure it out today. I don't know why my thing won't connect back to my earbud. It's just staying in the other one. And I don't know. Let me see something. But yeah, people, it's good to be back. Did not stream yesterday because I had nothing to do for chemistry. I have done all the stuff for chemistry so far. Do know that I have chemistry stuff to do next week, but I will do the stuff in between. But then I will also do some of it here. I will just rehash some of it here for the Monday stream, and also we'll work on something here for chemistry. Where is my phone? Because I think that's what's being confusing. No. Okay. It's not letting me connect to my earbud, but we'll just have to vibe without it, I guess. I guess maybe it's dead. Yeah, the earbuds are dead. That one, the earbud is dead. But let's get to work, people. We need to get to work. So I'm going to close this off. Thank you, Stream Beats, once again for your generous help. But we do not need you in this time of need. So we're going to close. Ah! My phone's falling. I really hope that this thing actually upgrades because I don't care. I just want the stream notification to go out. So people need to know, because I keep being recognized. And people are like, did you? Because like yesterday, the power went out because of the wind. There's too much wind in Montreal. So because there was so much wind in Montreal, power went out during my chemistry class. I still need to go and catch up on the stuff that we missed out on. But power went out, and because of that, we just weren't able to do the stuff. But someone in my class was like, "Yo, did your thing not like? Were you not able to stream?" And I was able to stream, so that was good. Also, look at this cool thing that I made. I made a time lapse of me, but I can't show it. But like I made a time lapse of me locking in for school, and it was very nice. I need to zoom out my camera. Put it back. Where was this? There we go. But I made a time lapse of me locking in for Math 204, so linear algebra. You can still see it over here. Let's switch over to the right file now. Okay, to math notes, so that we can have this all done. But yeah, I was going to test out DeepSeek today, but I don't think it's fast enough, and we need fast. We need fast work, bro. We don't need this slow Chinese nonsense. But I am in DeepSeek, and if it gets good, I will stop paying for OpenAI, because OpenAI is annoying, and it's good, but it's also like, you know, it's not pro-China. I'm just joking, bro. I'm just joking. But like, let's get to the work. Man. So today we're going to have some substitution questions, but the first question start off quite easily and will not have to do with substitution. So just like this one. Also, forgot to put the timer. So let's restart. Yep, there you go. And we're going to switch it to the calc and start up the timer. So let's go. So we're going to /int. I forgot. I didn't even go into the thing. Let's go. Let me see if I can find it. There we go. That's great. It connected to my phone instead of connected to the TV. That's great. There we go. Now we have the music in the right spot. And now it's not affecting my mic. Let's go. Okay, let's get back to work. We have 24 minutes left. So, if we're looking at this function, this integral that we have today, it is 4x minus 4x squared. It's the same thing that we did yesterday where we were just messing with derivatives, because we're going to get a set of functions and not just one function. And I know that now because I learned it in class. And it's just a lot of stuff, but it's annoying stuff sometimes. Because look, so we have minus 9x squared plus, no, we don't want it to be outside. We want it to be under, plus 1. And then dx on this side. Dx equals 2. And technically we should break everything into smaller pieces, or we could just do it once in one go because I don't want to. But I think it's better to be distinct and make it easier for future naming, in the sense that I will make it so that I have all of the things set up correctly. And also, yeah, last time I didn't do as much enters because I just didn't want to, but today I'm going to do lots of enters, like pressing the key enter, not like entering things. I don't know, because I don't think I need to do that at the moment. And then plus dx plus slash int, and then we have minus plus 1, and then plus slash int minus 9x, no, 9 divided by x squared plus 1. And then put the dx's. I forgot. That's why I was like, this one looks weird. But it was just because the dx was not there. What's the dx? Why is this dx looking different? Oh, okay. Weird. It feels off to me. Like this dx looks normal, but then this other one is not. Which is wild. Oh wait, I'm just tripping, bruh. I'm just tripping. So we got dx, and then that will equal to 4 minus 4x 3 divided by 3, then plus 1x squared divided by 2, then plus R9 R10. Let's go. That is the answer. So we're going to just take it over here and go over to the other side. Also, cool that I kept the timer. I usually don't use to keep the timer for you guys to see. But also the good thing about this software doing it this way is that it automatically switches it so that it automatically makes it such that I don't have to do all the weird caricatures. Sometimes I don't know what's wrong. Okay, and wrong. What is wrong is the question that we have. That's for another. You're not supposed to see that. Copy. Oh my. Let's use DeepSeek. Let's see what DeepSeek has to do. DeepSeek. Go ahead. Let's see if DeepSeek is fast enough to complete this, integrate the first one, integrate the second one. Oh, so it's not, wait, yeah, that's right. It's supposed to be X. Yeah, that's why. I was wondering, I was like, why did I add an extra thing? So then that's the only thing that I got wrong. And then this one's supposed to be minus. I see. So that's supposed to be negative, that one's right, and this one's supposed to be negative, and this one's supposed to be just X. So negative X or just X? Yeah, it's just X. X minus X, yeah. Why am I so wrong sometimes? Like, it's just crazy. So like negative, and no, don't put the double negative. And it should be right. Oh no. Oh no. Oh no. What did I get wrong? What did I get wrong? Oh, that's crazy. First time I'm doing that, guys. I did not forget. I forgot to add the plus C, and that almost cost me the entire question. Ah, that's crazy. Guys, that would have been very sad. Okay, our first substitution question. So, let's figure out how substitution works. I don't know how it works, to be completely honest with you. Let's go and find out how it works. So, we're going to go to indefinite integrals and the substitution method. So, running the chain rule backwards. So how are we going to do this? So du equals to du. Okay, so substitution, running the chain rule backwards. So but let's see the example. So x So we're going to set this one as u, and then this one as so it's going to be du equals to whatever the. So then this one stays that way. So we'll now do the. Okay, so it gets rid of the other one. I see. So the other one disappears, this one stays. Is what I'm getting at. I'm thinking. So you get rid of the other one, and then you just put in this, and then you substitute it back in, and you don't even change the thing. Because you don't do the. Do you do the antiderivative of that one? No, you just put it straight in. But it makes sense. So, interesting. So for this one, you have this. Okay, so this is how you're going to solve just pure root functions or whatever. because we saw this in class, and then they were like, we can't do anything with it yet. Or no, that was for negative one. That was for negative one, yeah. Sorry. That was for, yeah, x to the power of negative, or 1 over x. But for this one, what I have to do is that I just have to make it u, take out the thing, make it u, then you have to bring the thing over there, and then 2. Well, where are you getting this 2 from? So the 2 does not fit the fill u and du with u because du dx. Interesting. So to fix it, you move this one out and you make it 1 over 2. So du equals to 2 dx. Interesting. So for this one, you just make the u, secants, boom, that works. So for this one, you do the same thing, where you just put the u, but then because you have the 7, you can't do it directly. Wait. No. Why do you have to remove the 7? So for this one, you don't have to move the 5 out because it's your bestie, Miss Westie. That doesn't make sense to me. Oh, because it has the 5dx or whatever. So you have so if it gives the thing, you have to figure it out that way. Interesting. So when it has the 5dx, but ours doesn't have that in our question. Ours is just like an x whatever, and then you just do it that way. Okay, because I'm seeing this 5dx, and it's just, you have to track. So there's 2 things that we have to track. So we have to track not only the formula is this. So the formula is this, like un equals to du. So, but we have to define both u and du. So for when it is, yeah, so u is whatever, and then you put the raised to the power of n, and then you have the du. Du will now be du, the derivative of dx. The derivative of dx equals to that. So for this one, it's 2. Interesting. So for the other one, so if I had, yes. So in this case, I would have, where would you put the u? U here, 1 over, what? Okay, so for this one, x squared, x whatever, is the derivative of e dx. So then x3 will now be the u. So EU equals to 1 over 3 du. And you say that du equals to 3x squared. So the derivative of x squared, no, the derivative of x cubed. So, okay, so it's the derivative of u. So you use, okay, let's go back up here. So when we're using du, it's the derivative of dx. So du is the derivative of dx. So then dx, what we have to find, so, oh wait, so are we doing the antiderivative here, or are we doing, wait. Okay, so on this case question here, we have du dx. So the derivative of, so we set u to this, which is this part, and then this du equals to du dx. So then it means this, wait, so du equals to du dx, and then, so that equals to 3x squared dx. So then this is, I'm wilding out, bro. If du is anything, wait a second. So d over dx. So like, we're going back to the antiderivative rule, where we have d equals dx, u plus n plus 1 is divided by n plus 1. That's just the normal one that we have. The derivative of that is u du dx. Un dx. Du over dx. And then the integral of un du dx equals to un plus 1 n plus 1. This, then the simpler version is just un du equals u. Okay, so this is the way that we have it. So this is the three things that we need. We have these three things. So now, to solve, you can now have du equals to the derivative of u du derivative dx, which would now be, in this case, this. So whenever you have two things, whatever is your u, you will set your u. So this one will be your u, and then this one will be your dx, and du over dx. And then you keep that, move it here. So then it's just going to carry over. So then you'll do the derivative. So now u is this, so you just do the derivative here. And then, but I'm confused why the one in this one, it disappears. Because in this one, it shouldn't disappear because it's now, because in this one, you have u5, u6, and then the du disappears. Where'd the du go? Are we just, wait, is the du just disappearing in the same way that we don't care about the dx in the normal one? Wait, so in this case, we have, in this case, we have 1 over 2 dx plus 1 dx plus dx. 1 over 2 u plus 1 over 2 dx 3 over 2 plus c 1 over 3 2x plus 2 1 over 3. Okay, so we have 1 over 2. 1 over 2 brings out here. But how are we, wait, with t, okay, so when we're in this one, know that your u is just going to be the one inside the thing. But it doesn't fit the formula because du equals to 2x. Okay, so on this one, the derivative was the derivative was 3x. The derivative of, wait, in this one, we don't have an extra thing here. We only have the un thing, which is raised to the power of n. And then, but the derivative of, I'm confused, bro. Because like you have dx here. So it's not precisely dx. So because it's not dx just times 1, you have to bring the constant 2. So this 2, which is from here, which is from here, which you do the derivative of. You do the derivative of 2, of u. Okay, so in this one, the derivative of u was, no, this one, u and du. I'm confused. Let's go back up here. Yeah, I know the arbitrary C, whatever. But in this one, we're confused because you have un plus t, un da da da. What happened to the? Okay, no, I'm gonna say so un du da da da. So your derivative of this gives you un du dx, which makes sense because this is just the power. No, it's not the power rule. This is the chain rule tells us that. What is let's check the original chain rule. Let's check the original chain rule, bro. So the original chain rule says that dy equals du, dy, du, whatever. So it's just like that kind of thing, like that. So now, if we go over back to the indefinite one, where we're having dy dx over this equals to un du dx, which is wild since the chain rule states, because this in the chain rule where we have it is that you have the u and then you do the derivative of the u and you bring it out for this one, so it'll be 6x whatever, and you get that kind of thing. So the derivative of that's the expanded thing, but we don't care about that. So okay, so if I go back here to the integrals here, let's look at this one. So for this one here, the first thing that we have to do is that we define this one as u. And by defining this one as u, this automatically becomes 3x. It just by definition is the d whatever thing to connect it. So now, because that is it, and this is so complicated, it just disappears. So we integrate according to u, and we get rid of the du, because du just gets rid of it like that way. But for this one, it doesn't fit the formula because we don't have a du. So to find a du, we need to bring out the I'm confused because we have the 1 over 2, n over 2, and where is this du? Why is it? Where is this 2 coming from? I'm squeaking, bruh. Also 6 views, that's crazy. Bro, I'm confused. I don't know what to do. So like, why? So the substitution method is this. Substitute u for gx. Du is now the derivative of dx, which equals to gx derivative d. Why? What? Just why? Why is there so many y's and x's, bruh? Also, thanks Dola for showing up. Like, and can't wait to see you in a bit. Like, once you come back over, when you're here in Concordia. But right now I'm struggling. What is du? What is whatever this nonsense is? Hi. It's such an annoying thing. So we're doing the chain rule backwards. But what is the chain rule? Let's ask our good friend DeepSeek to help us out. Explain the substitution method. I'm going to learn this again tomorrow, but like, who cares? The substitution method is the technique to solve systems or whatever of linear equations. The set of one equation for one variable, whatever. Give me an example. So, no, not substitution method. I mean substitution method for integration. Ow! We're still learning, so we'll take the short break while learning. Okay, so let's evaluate this. So, okay. So, in this case, what we have here is we have 2x, x squared, x squared. So, we'll say that let u be this. So then, the derivative of u is 2x, or du equals 2. Wait a second. Okay, so when you have the du dx, you'll now multiply by dx to make the 2x on that side. So it is basically a fraction, but I was just tweaking and not treating it as a fraction. I'm bugging, bro. I am bugging, bro. So let's look back over into this one then. So du equals to du. Why did they write it like that? That's annoying. So like in my case, what I have here is that, but the derivative of 3x squared is not nothing. It's something, isn't it? Wait. Wait. I just figured it out. Oh, that's just annoying. Because, so, for this example 1, it's not a true question. The question should be just x3 plus x raised to the power 5. But they simplified it and brought the thing out. So it's not a real question. So the question itself is not this. This is not correct. So for my question here in the web work, where I have x, whatever, that, and the thing is that, what I have, I'm still lost. Because now the x will now be used to, oh God. No, that is, yeah, it is the same way. So like you have the x here, so the x is connected to this dx. So now the x dx is now the du, and then you just do the thing, and then you just go 7x squared, and then it'll just be 7 plus x squared raised to the power 10, raised to the power 11 divided by 11 plus c. I'm so angry at this thing. So now on this one, it actually is the right thing because you don't have the du on this one. So what you have to do is bring out the du by doing the derivative of this, of the x, of the u, and then you get out the 2. So then you have the 2 there. And then what you'll now do is now, why would you extract it? Well, now I'm confused. So now we have the 2, which you bring over to the 1 over 2. Why are we bringing it out that way? Why are we making it 1 over 2? So it's missing from the integral, and as such, we move it out to be just the 2. So this is du, and because we have 2 dx, because we don't want this 2 dx, we'll move it out to be 1 over 2. No. What? So it'll be 1 over 2. Where are we getting this 1 over 2, bro? Oh, because the 1 over 2 doesn't really exist. So because the 1 over 2 doesn't really exist, we're compensating by putting a 2 times 1 over 2, which technically takes out the 2 already. So then we bring the 1 over 2 out, 1 over u over 1 over 2, whatever. Do the thing so that you get 1 over the thing. Then you multiply it through, so then you'll have 2 over 3. U of 3 over 2 times 2. So then it'll be, you cancel out 1 over 3. 2x plus 3 over 2 plus c. Yeah, that's the way it is. Ah! This is annoying. This is annoying on several levels. I don't like it at all. Okay, so then on this one, we don't have to do the derivative. It's already been brought out because it's times 5 dx. So then you just have it that way. Put it through, do, boom. This one, you have to bring it out, put the 7, put the 1 over 7 in the front, then do that because the 7 technically doesn't exist. Or it does exist, or maybe it doesn't. I don't know. All I know is that it may or may not exist. And we need to compensate it for it actually being there. So I think it doesn't exist. So for all intents and purposes, when we have a 1 over 7, you bring the 1 over 7 out because that's just the way it is. Okay? So for our question, it will be, we don't have to do that because it's already x. So then it's x times dx, which gives you 1. So it'll be 7. So it'll be 1 over 1. So then it's just, yeah. Okay, so let's do this. So let's write it in Word first before I put it in the other thing, because I like putting it in Word. But like, why? It doesn't make sense. But like, I don't like it. I don't like substitution method. But it's the trick that makes integrals super easy. That was the clickbait that I used for the title of this of this stream. Even though I didn't know how it worked. Like, let's not lie to ourselves. I didn't know how it worked. And I have friends that have already done this. I have a friend that has already done this whole thing. So, that's something. It's already 11:23, brothers. I need to sleep, but I don't need to sleep. Also, who is lol, bro? Whoever it is, I'm very grateful that you're telling me to keep up the grind because I am struggling. I'm struggling, bro. And I'm not going to die. I need to make several videos before I die. There's at least 2 videos that I need to make before I die. And one of them involves the time lapse that you may have clicked to join this live stream, and I am grateful. And also I'm very grateful for everyone that joins these streams and the small amount of views I keep getting, and it's just like, let's go. Every time I look at the YouTube studio and I'm like, yes, more views, guys, more views. One day it will transform into money. And if you're here, I don't know why no one subscribes, and it's kind of sad that the people keep joining and then they just don't subscribe, and it's just very annoying. It's very annoying that they keep doing this, and then they're like, I support you, brother. I support you. But like, if you support me, press the button, or at least press the like button, you know? But like, none of them do that. And if you do that, I will salute you. For real. Also, I need to get like the things back, the notifications, so that I can actually see like if people are actually obliging to what I just said. Because I don't have those I haven't used those in a while because I wasn't having subscribers back then. And I wasn't consistent either. And I've now done streams for like 2 weeks now, and that's longer than any period of time I've ever done. Also, why isn't this converting into why? Come on. Why? Okay, I'm going to leave the TV home. So I'm going to put this, then put the x squared, and then put the raised to the power of 10. There we go. and then it's dx. So then what we're going to now do, we're going to put the dx, then we'll put the equals. I don't care. I don't want to do it in this. So goes there, equals, and then we'll take away this equal. I don't need it. So then we'll take the equals. Then we'll put the int, and then we have the x. Thank you, brother. I respect that. I respect that. I respect that. I respect that. But now I will do that every single time. I'll have a banner there. It's like, if you are a friend of mine and I know you in real life, it is lip service. It is lip service to be like, I saw the stream and I enjoyed it. Give me proof. I don't believe you. I don't believe you. If you say otherwise, I won't believe you. Also, why am I typing it again? I'm not supposed to do that. So it's supposed to be U10. Oh, let me just do it again. U10, then times 7. And then the U. Then we go what is it called? Yep. So then that's that, and then you just have the actual thing, which is U11 raised to power 11 divided by 11 plus capital C. But that's not that's the answer, so you have to kind of extract this out of everything. So now we remove that, boom, boom, and then which equals to then 7 plus x squared over 11. So then that's what that is. And I don't know if this will accept, because last time it was kind of annoying. But let's preview the answer and see if it's correct. And yes, and no. Oh, that's annoying. So this is, if you haven't seen these streams, this is what I always do. And now we're using DeepSeek because that's whatever. And I think I've gotten the concept right. It's just I wrote something wrong. And usually I should check myself first, but y'all, these guys are crazy, bro. Nah. Every single time. I keep forgetting. So because you have the x, that's annoying. So you have the x on this side, which just brings out the x over the thing. X dx equals to du over 2. I completely forgot about that. Interesting. Because I thought that was the derivative already, but it's not, because it's the derivative of x is 2x. So then it's going to be like that. So then du equals that, and then blah, 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 and then okay. So this struggle is wild. I don't like it at all. It's annoying. Because I know what is going on, but let's show what's going on here. So I've become adept at reading corrections from ChatGPT and alternatives. And DeepSeek is not bad at its job, I'm not gonna lie. And it's not slow. So like we vibe with it. We vibe. So this equals to not du, but actually, so should we define the du? Yeah, let's define du somehow. But how are we going to do that? I guess we'll just say that it kind of interrupts the flow. But we'll say u equals to, yeah, that works. U equals to 7 plus x squared. Plus x squared. And then for the other thing, For the other one, we got, oh yeah. So then you have du equals to, yeah. So du dx equals to, no, yeah, du dx. So the derivative of du dx is 2x. And then we have the x on the other side. So we have x dx equals to du dx du. I'm confused. Okay, so let's go back to our actual equation, because I'm trying to figure out how to solve and show what I'm solving for in the actual thing, because they're confusing. Because even DeepSeek is annoying to me. I also like saying DeepSeek. ChatGPT is such a weird thing to say. Like, not gonna lie, but like when you're saying DeepSeek, it's like DeepSeek makes sense. But like ChatGPT does not make sense. Like, it just doesn't make sense to like actually say. So then this is 2x, and then this is 2x. Then you multiply by dx, or wait, no. So du, so you're solving for du, right? So x dx equals to whatever, and then du equals, okay. So du equals dx, and then dx, du, yeah. So then that's that, and then so du equals to 2x dx. So based on that logic, x dx equals to du divided by 2. Because just based on basic like logic, right? And I think I need to separate this because this looks disgusting. Like, it just does not look appealing to the eye. How do we separate this? I don't know. Dx equals to dx equals, yeah, so then that's equals to that. But I want to make this look separate because it just doesn't look good. I want to help future Damie, but future Damie doesn't want to be helped. Or maybe does. So if we do, no. Okay, we're gonna leave it that way. No, let's do it this way. So u equals that. If we can, wait, I think what I'll do is I'll just cover the whole thing in brackets or whatever. And then, no, brackets won't help. What we need to do is, I think I'll just put it all in the absolute function for no reason whatsoever. But like, okay, it's just an absolute function, and we'll now know that it's an absolute function, guys. It's an absolute function. So now we have that. So then this is du over 2. No. 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 I don't want that. I want to just divide the du over 2. Oh wait, yeah, that works. Yeah. Forgot about that handy dandy tool right there, where you can just do this. So then you have du over 2. So then to counteract that, you have to bring the thing on the other side. So so bring this thing here. Okay. Boom. So then this equals to 1 over 2 and then this one goes back to just being du. Boom. Capiche? So, so then you have 1 over 22 c dot boom, and then that will now give you the exam answer that you need, which is 22, and then that's the thing. No, don't put 22 there. You just put it over here. So then that gives you 22, and then that should give you the right answer. So let's preview the answer before we press it, and that's the answer. Hallelujah. I am glad we survived. We made it through. We made it through, people. Let's go. But now I am done. I'm not doing this anymore. It's almost midnight. I'm going to do more work by myself. But thank you, people, for joining me for about an hour. I'm glad that I am here, that this has been a great stream, and I figured out basically how the substitution method works. We'll do more questions in future episodes, and most likely, and also in the mega stream on Friday. So we'll see. See you, people, in the next stream. It's been nice knowing you. It's been nice seeing you. Goodbye.